Got it. Anilox Roll Clean Systems, correct?
But that is company one, correct?
Company one.
And the sister company, another one that I oversee, is called ESCA Industries.
Okay.
And it's also known as ESCA Blast.
Okay.
And actually, you can't, let's see, let me stand up for a second.
Yeah.
There it is, okay?
Yeah, I see it.
Yeah. But these two companies are all under the same roof, and they, in many ways, they are independent of each other. And the ESCA business, on that side of the coin, we are suppliers only. So we don't do any contracting or projects per se. However, we supply contractors, we supply government, we supply corporations with all different kinds of surface preparation equipment. And the common term is sandblasting, but the market or the industry is better described as surface preparation.
Okay.
And there's a full range of activities that fall under that umbrella. But that's what ESCO is all about, Tom.
Okay. Yeah. And so for anyone that didn't watch it, we did an episode a week ago today. So I think episode 180, whatever it was, we did laser cleaning. And yeah, we were mentioning the different. I say you were mentioning, and I was nodding like a moron. But one of them was dry ice cleaning, and
Yes.
I thought that was the coolest thing. And you picked up on me clearly getting excited, and so yeah, unlike last week, I don't know anything about this, so I'm actually going to take a break from my normally scheduled rambling during every episode, and I'm going to kind of sit back. And I had a guy on the last 2 weeks. One guy gave a history of the vacuum tube. And
okay, I saw that one.
Yeah, that was very and he saw yours. He saw the laser cleaning one. So got some dual watching. But with those episodes, I'm finding, as much as I'd like to think I'm well read, there's a lot of stuff that I don't know anything about, and this is something that, to my own ego's dismay, I know nothing about. So I am going to sit back and let you teach me about dry ice blasting or surface preparation.
Yeah.
The floor is yours.
Gotcha. Thank you. So it to me is a very fascinating industry. I got involved back in 2007, so have a decade plus now in the trenches, if you will. When people hear the term sandblasting, they probably think of something that's messy and hard to do, and almost, is there any other way to prepare the surface besides sandblasting, right? Like a method of last resort. And that truly is old school thinking. The sandblasting conducted today is just way different than it was, 10, 15, 20 years ago. One of the couple of big differences, one is the introduction now of all these different kinds of medias. And media, we're not talking cassette tapes or DVDs, right? So that term media is also used in the surface prep industry. And it's just referring to the aggregate or the abrasive or the powder that someone's using to achieve a certain kind of finish on a substrate. So it ranges from what we refer to as non-destructive media, which would mean it's very soft. It has some properties or characteristics that allow it to either clean or abrade a surface. But ultimately, there's so many different eco-friendly choices out there today. That's why I said it's just way different than the sandblasting that was conducted, years ago. And if you go into the history of sandblasting, it's a process that was developed a long time ago, back in the early 1900s. So it's been around, for a very long time. And just the basics of sandblasting, for those that aren't familiar with it, it's a pneumatic operation. So any type of blasting operation gets powered by compressed air. Mm-hmm. And that compressed air can come from a variety of air compressors. If you are working in a manufacturing plant, typically those plants already have house air of some sort, and you can plug a blaster into their air system and use it in a plant environment. You can also do field projects, and in that case, you would be using an air compressor that is fueled with diesel or gas, and it would be an air compressor that gets hitched to your vehicle and towed around. And then there's electric compressors too. So we supply, ESCA is based outside of Philadelphia. We cover the nation, and certainly our backyard is all of the Northeast, including New York City. In New York City, we have supplied some real large projects where you can't park an air compressor anywhere, and they might be using an electric compressor instead to overcome that issue of space in an urban environment. But no matter how you slice it, compressed air is still how you start the process. And then with different kinds of blasting, it kind of boils down to these days either dry blasting or vapor blasting or wet blasting. Dry ice blasting is very unique, and it's a niche. And maybe I can kind of explain all of this by going from dry ice blasting, which is absolutely non-destructive blasting, and then I'll start to explain other types of medias that become harder and more aggressive than, say, dry ice, and kind of go through that range, if that sounds okay to you.
That sounds awesome, man. I'm like I said, I'm sitting, I'm giddy. I'm like, all right, let's go, let's do it.
All right, so let's start with dry ice. And dry ice, out of everything else I'm going to discuss, is really the only media these days that requires its own type of blaster. So it's dedicated equipment. Dry ice is minus 107 degrees, so ultra cold, right? And dry ice is also found in other markets, right? It's used to keep food cold and to make fog at a concert, right? There's other reasons people use dry ice. But in the world of blasting, what they have figured out is a way to pelletize it. So when someone's ordering dry ice for blasting, it comes in a very large 500-pound bin. And when you open the lid, what you're going to see are these 1/8 inch pellets. So it looks a lot like a very large rice pellet, right, or a rice grain.
Okay.
And what's super unique about dry ice is it sublimates. And sublimation, the definition of sublimation simply means it's skipping the liquid state, exactly. So from a solid pellet, it then turns immediately into a gas. And therefore, one of the appeals of dry ice blasting, it's not making a mess. It truly is one of the cleanest blasting processes out there from that standpoint. So you still have primary waste, right? So if I'm dry ice blasting a printing press, and that's a very common application for dry ice blasting, I am removing dried ink, maybe dried glue or adhesive off of the press frame. And when I blast it with the dry ice, what's happening is there's three things happening all at once. So the sublimation is occurring, and that truly is an explosive effect. To go from a pellet to a gas is, from a physics standpoint, a very powerful process. So there's this explosive effect that occurs that starts to erode the dried ink or dried glue, let's say. Then you have a mechanical aspect to this, and you are shooting a solid onto the surface, and that is, just creating some agitation or some impact is a better way to say it. And you're firing the dry ice at, depends on what you're doing, but the range is anywhere from a 20 PSI, which would be very gentle, all the way up to over 100 PSI, which all of a sudden that, you're not going to put your hand in front of that. It's designed for impact and for effectiveness. And then that third process is just the temperature, right? So if you're hitting something at minus 107, actually it might be 109. I know it's minus 107 or 9, forgive me there. So, but it's still super cold, right? So, and so you're freezing. And if you think about glue, especially, certainly much easier to remove glue when it's brittle and frozen than it would be if it's gooey or room temperature.
Mm-hmm.
So all that's happening, all at the same time. That's the dry ice process. And where it's used more and more on the industrial side, press cleanings, press frames, people that have molds, so plastic manufacturers, injection molding companies, they have a need to clean their molds these days frequently. And there's equipment that can be used in a plant. And when that mold is ready for cleaning, you can very quickly clean it out. Usually there's outgassing residue or other remnants of the injection molding process that need to be removed to maintain quality. And a dry ice blasting is a really good way to do that. So, and then beyond that, Tommy, fire damage or mold remediation can now also be done with dry ice. You can also use baking soda, but there are two ways to skin the cat for those types of projects. But dry ice absolutely is a wonderful way to remediate, for those types of projects where a disaster has occurred in someone's home. They hire a contractor, and that contractor may show up with dry ice equipment that's going to be used to remove all the soot, smoke, charring even, and restore that house to like it was before the disaster.
Is there any use, and this is obviously it's not the sublimation, because that's one thing I always remember from general chemistry is I said I wasn't going to talk, but here I am. This sublimation, I remember that, and I remember it was the opposite. Is it deposition? Is it gas to solid? I don't remember, but not important.
I'm not sure, actually.
Yeah. Is there like a sweet spot? Because you're right. When it's very cold, it's just like when you got like a smudge on your desk or something. I mean, what do? You get hot water, right? Get that molecular vibration up and just get it right off. Same with cold. Much easier to go in and just break it off, right? You go into the woods, going on a summer day, you got these living moist branches, you break them and the wood's green. Exactly. You can't break that off, it's bendy. You go in northern New Hampshire, where I'm from, you go in January, you can just touch it and it shatters, right? Like Terminator. Is there a sweet spot though? So obviously you're not going for complete destruction, you're cleaning sensitive equipment. You wouldn't, granted it's not a solid, but you wouldn't want to go like liquid nitrogen, right? Because that is, I would imagine that's just sheer destruction, versus you want to destroy the contamination but not the actual thing that you're cleaning, right?
Right, yeah. So when we say non-destructive cleaning, essentially what we mean is we're targeting what's on the surface, any type of contaminant or residue, and we're not destroying the substrate. And so you're absolutely right. It's designed to do very delicate cleaning at times. So in a plant environment, it can be used on electrical gear. It's used quite a bit because it's also a waterless process. So it's a safer process than, say, using chemicals or things of that nature. But it can truly be, I've seen dry ice used for, cleaning circuit boards. That's how gentle it can be.
Okay.
And you would be using these, real special pencil nozzles and going at a very low pressure, but absolutely, dry ice is now considered a way to perform that. It's a technical cleaning process, but the reason it's used is because it's not doing any harm to the underlying surface. So that's a key part of it. I mentioned, so the other appeal was the lack of waste. Mm-hmm. But one watch out would be for anyone considering the process for a project, you still have what I call primary waste. So if you are removing the dry glue, it's not magically disappearing. It's still coming off the equipment, and then it's going somewhere. And with some good technique, you can make sure that as you remove the substance, it gets directed towards the floor or the ground and goes into one specific area. But boy, that's still way easier than trying to clean up. So we're going to talk about the abrasives that don't sublimate, right? Mm-hmm. And with those, it's an equation, right? It's primary and secondary waste that you are responsible for containing.
Okay.
But dry ice does eliminate a big headache from a containment standpoint. But some people get this impression it's just like the laser, like we talked about previously, like somehow that truly was vaporizing the contaminants. That's not the case for dry ice.
Do you ever do like a 1-2 punch, dry ice followed by laser? Get the dry ice for the bulk of it, like, it's like you're chiseling a statue and you start with your block of marble. You don't start with sandpaper or a Q-tip. You start with the jackhammer, right? Yeah. And then when you're getting in that like Michelangelo or whoever one of the great carvers was, sculptors, right? You go in with the same. That's how you get those. You see those old Roman statues where you see like a hand gripping an arm and the fingers actually you see it pressing into the skin, and it's like, how did they do that? And it's because they went in, or they're just. They were removing millimeters at a time. Yeah, but you don't start like that. You start with a pickaxe and a bottle of whiskey, and they're just going at it like like crazy. Would you ever use that? Would you ever use that sort of 1-2 punch, dry ice to get the? Granted, it's all relative. A lot would be say a millimeter versus the billionth of a cubic micron with the laser. Is that it? Is that a 1-2 punch, or I need to stop interrupting you?
Well, I know it's funny you said that, because here's the deal with dry ice. So it's non-destructive, and there are some videos out there where people will see, oh, look, at dry ice can depaint my car, or dry ice can also strip paint, and that's not quite accurate. So generally speaking, if the paint is failing, dry ice can start to remove what's flaking or ready to come off the surface. But if it's well-bonded paint, you would be there forever and spend a fortune before you could effectively remove all of the paint you're trying to remove. Mm-hmm. So we have supply projects where exactly what you just described. So they want to use dry ice as much as possible. So if they are just a wall on a building, right? So they take the paint off of cinder block. They get as much as they can with the dry ice process. Still eliminates a lot of the cleanup and containment. And then they could very well come back and hit it with a harder abrasive for those areas where the dry ice did not work too well.
Okay.
And actually, Tommy, so this is what's brand new in the industry is so the dry ice equipment manufacturers recognize what I just said, that dry ice, as good as it still can't do everything. So they now have equipment on the market. We just installed one a couple weeks ago, the first time we did this, where the equipment accepts both dry ice and other medias. So all of a sudden, in the same package, you can dry ice blast, and when you come across a spot that the dry ice cannot tackle, you can flick the switch, and all of a sudden you might be soda blasting. Soda is actually more aggressive than dry ice is, or you could be doing some other form of media blasting, all with one machine. It's funny because the dry ice equipment makers of in years past, they always try to position dry ice as the holy grail, like they can do everything. But finally, there was acknowledgement that, you know what, it's probably not in our best interest to continue to promote it for depainting a car, because it in reality just doesn't work. Yeah. So, and instead they went back to the drawing board and came up with some really neat equipment that, like I said, is multi-method now, and that's that is just, to me, it's neat to see that type of innovation in my industry.
So I was just thinking, what is there? Yeah, so dry ice, like you could use dry ice to remove paint from a car, but it's almost like it's like an analogy I had heard. It's like using Hennessy for water ballast in like a ship. It's like, yeah, it's a liquid, But I mean, it's $80 a bottle. Use seawater. It's free, right? It's using Cristal to put out a forest fire. Like, no, you just need liquid. You don't need this nice wine or champagne or something.
Right.
Is there, and I think you were getting to this, is there a progression from dry ice? Like, okay, you want to blast the paint off your car. You don't want a laser. You don't want a dry ice. How does it morph for different, I guess, clients, if you will, or projects?
Yes, a perfect segue. Thank you for. So let's move on from dry ice, but that's the basics right there, and certainly anyone watching this wants to dive deeper you can find me, right.
So I'm listening. I'm getting a fan. My laptop is you can definitely tell this isn't a laptop for podcasting. It's overheating. So I gotta, yeah, I know, right? I gotta put a little fan in here. Sorry for technical difficulties. Excuse me, everybody. And we are good. Sorry about that. It's this laptop. It starts spooling up like a jet engine sometimes, and there's no rhyme or reason. Doesn't matter if it's Zoom or Skype. 20 episodes, no problem. And then you'll start doing an episode, and it's like, and I'm like, okay. So it's jerry rigged. I got little fans everywhere. Sorry for the interruption. Back to the segue from dry ice to next.
So let me start with just mentioning what we talk about a lot in this world of blasting. It's the Mohs hardness scale, MOHS. And it is a simple scale, 1 to 10, 1 being talcum powder and 10 being a diamond.
Okay.
So dry ice registers at 2.0 on the hardness scale, so that's why it's non-destructive, a soft, gentle media, and therefore won't take a thick coat of paint off of metal, right? So what we offer are medias that have all different hardnesses. So the next one on the scale that we are involved with is baking soda or sodium bicarbonate. That registers at 2.5, so a little bit harder than the dry ice. The other aspect of medias and how they perform is their shape. So a crystal of baking soda under a microscope would look jagged and sharp, and it is. So but soft. So again, it's a very unique media. So it's the same process, right? We're using an air compressor to power a blaster, and instead of dry ice coming out of the nozzle, now we're shooting baking soda blasting. It's a process that was discovered back in the 80s when the Statue of Liberty was being restored. And the statue and it wasn't the outside or exterior of the statue, it was the interior copper lining.
Okay.
And very thin, very delicate, in need of restoration. And the first step was to clean it. Long story short, they stumbled upon this process of using baking soda, and it worked wonderfully. And P.S., this whole soda blasting industry was born, and it's come a long way. So, but the soda, the technical term for a media that's soft but breaks up upon impact is called friable. So soda has a friability characteristic to it, and it just means that when it hits the surface, it's exploding or breaking up upon impact. So it's not sublimating, right? Because I know I use that word explode with the dry ice. Mm-hmm. That still refers more to the natural process of sublimation.
Exothermicity.
In this case, the soda is being delivered onto the surface, and when it impacts the surface, instead of digging into the surface, instead of that energy carrying it forward into the metal or wood, it's actually stopping. And as it stops, those crystals are breaking up upon impact. And just think of, so the soda crystal looks like a knife under the scope, and all of a sudden when it hits, it subdivides. And instead of one knife, you have 100 knives doing the work.
Okay.
And that's how soda is able to soda can be used to depaint a car. Soda can absolutely remove some very tough coatings. Teflon coatings, piece of cake for soda blasting. So it's all about when someone still has a need to do non-destructive cleaning. They don't want to damage this underlying substrate, but they have a tough coating to remove. Baking soda is truly one of the only medias that can achieve that outcome.
Okay, yeah, I remember, stupid segue, I remember in college we stole a fire hydrant. It was an old fire hydrant, but it was in the woods. Not really stole. We took it and we painted it red and black, UGA, go Dogs. We brought it into our apartment, and I remember we put it on the wooden floor, and we dropped a beer pong ball, and I remember the beer pong ball went towards it and then started going around it, and we realized we had created like an orbit, right? Because it was pressing down the floor. But all that to say, I remember who's now a physician, saying without missing a beat, he was like, well, pressure is force divided by area. He was like, this is too much in one spot. And so that's okay, that's baking, or that's the knife, right? You got a big knife, and instead of that sort of non-forgiving, you ever see someone fall and hit their head on ice like a frozen lake? If it breaks, that's good. That's a lot less, the moment of impulse is a lot less on the skull, right? It's when it doesn't break, that's when it's like, uh-oh, because it was all delivered. So it's okay, you're not hitting, you're not digging in. It's sort of like it's changing the hose to that like soft spray, if you will. This is, if you can't tell, I have weird ways of learning, but but that's how, so you hit it and it's, okay. Sorry, again, I learn out loud. I explain it to no one in particular, so I'm noted. Sorry, go on.
That's cool. So, and again, so a common parameter for all of the blasting we're talking about today does include your blast pressure. So, and again, blast pressure is measured in PSI, pounds per square inch. And truly, today, there's equipment on the market that can blast at a very low pressure, like 5 PSI. Okay. So 5 PSI, I could put my hand in front of a nozzle and it's not going to hurt me. I don't recommend that, but just for demonstration purposes, we show people that at 5 PSI, you're actually not blasting, you're cleaning a surface. When we do demonstrations, we can take someone's business card and we can remove their name or logo and not do any harm to the cardstock. So that's how gentle soda can be. And we can do that also with dry ice. You can do that. It's a little bit different, but it's the same effect. And there's another media called calcium carbonate where we can show people how gentle the process can be.
That's a showstopper. Take the business card and clean it.
Actually, so there's videos out there of that going on, and then there's even you can blast a Coke or Pepsi can, and you can have that go down to bare aluminum.
Whoa.
And with all the ink or paint, and again, it's showing how gentle the process can be. So we work with National Park Service, we work with conservators. So in this world of historic preservation, they cringe at the word blast. Their job is to preserve history, and therefore do no harm is the philosophy in that world. So we're plugged into that network quite a bit, and therefore, they absolutely want to make sure if they're specifying a process to restore a building, to clean a facade or a monument, that whatever is being selected is not going to do any harm to the actual object or to the building surface and things like that. So
what's the
soda blasting? I could probably talk the whole hour on soda blasting because there's pros and cons to this stuff. But in terms of, being able to fit in the other stuff we want to cover, I can just tell you this, from a chemical standpoint, the fact that it's sodium bicarbonate, that's a watch out. So it contains salt. So we would not recommend soda blasting for a brick or masonry building.
Okay.
And the main reason is it's a term called efflorescence. So without getting too much in the weeds, if anyone has driven by a brick building and seen a white haze on it, the white haze is efflorescence. what you're seeing is dried salts that have come out of the mortar or sometimes directly out of the stone. And if you are applying baking soda to that condition, it makes it worse. That's what it comes down to. Okay. So there's alternatives to that, but that's a watch out. You want to make sure you're not soda blasting something that shouldn't be soda blasted. It will yellow out your landscaping. Usually, people don't want that to happen. Won't necessarily kill everything, but it can create an eyesore pretty quickly. So we always make sure people are aware of that, and we train people on how to avoid that situation from occurring. And the last watch out, and then we can move on, would just be soda residue. So post-blasting soda residue needs to be rinsed off. If you are going to repaint a piece of metal, you just want to make sure there's no soda left behind. And if you don't do that, new paint will not stick. That you're going to create an adhesion problem. So
isn't that
make sure people understand?
Isn't that a problem in Dubai? All the skyscrapers. I mean, they've got oil money. So, and by the way, I know it said fit it in 60 minutes. You can do 1 million episodes, man. If you want to grab one topic and expand on it, go for it. There's no agenda. There's no schedule. I appreciate that. We're our own bosses, man. We can do whatever we want.
That's right. That's right.
But in Dubai, aside from having that oil money where they can just crank up the air conditioner and still have a glass facade on a 200-floor building, right? And don't worry about that. Just complete, middle finger to Mother Nature, the sun beating in there and turning up the AC. But a big problem they have, and why they clean the towers nonstop, think the Burj Khalifa is what, 2,712 feet tall, 827 meters?
Is it?
Yeah, it's insane. It's over twice as tall as the original. If you stack the original World Trade Centers on top of each other, right, taller than that, it's insane. But
I didn't know that. That's crazy.
It isn't. I mean, I love skyscrapers, and that is another episode for another time. For 100 years, everyone kept doing each other up by like 5%. Burj Khalifa came in and outdid everyone by, it was something like a 30 or 40% in terms of height, because up until then it was Taipei 101. That's why it's been the tallest for about 10 years, which in skyscraper terms, aside from the Empire State Building, that is a kingdom. That is a dynasty. You don't last that long. So point B, I need to find someone on for skyscrapers. They have to clean it nonstop because where is it? It's in the middle of the desert. And they say the biggest destructive force to it is it's not wind. It's not physical degradation. Well, it is physical degradation. It's the salt blowing from the sand. Yes. They said that destroys it, which is why they clean it nonstop.
I'm sure.
End of rant. Sorry. So yeah.
So definitely, I mean, there's many ways to clean a building, but media blasting is becoming more popular because the alternatives are power washing or a use of some sort of chemical agent. They all have their risk. Power washing sometimes can do more harm than media blasting. Chemicals usually used for cleaning buildings are acidic in nature, so not only will the operators be exposed, but the building itself reacts to that type of acid cleaner, like a muriatic acid or something of that nature.
Yeah,
so, so one last point, just so where is soda blasting used, right? It's very popular today in remanufacturing. So think of like we deal with big companies, they're remanufacturing engines and motors. So when they first come into their shop, they're breaking them down. The very first step of any reman operation is cleaning. Soda can degrease, take the oil off of old parts, and reveal what the remanufacturer is up against. What do they need to repair and fix before they can sell it again? So very popular in that whole, that's a big industry and used quite a bit. And I mentioned, so fire restoration, mold remediation, very popular. Sometimes graffiti removal, sometimes not. And really, it's still used in the automotive industry to a certain degree. And it used to be used a lot for boat bottom paint removal. So soda, again, because of its gentle nature, it's not going to harm the gel coat or fiberglass found on a boat.
I wonder.
That these days, but that's where people would find soda blasting being used as we speak.
I wonder if there'd be any like removal use for, because I know for the Apollo astronauts, something they like discovered while they were up there was just how dangerous lunar dust was, because it's microscopic, but it's like hyper sharp, and it's like I mean, it's like worse than sand, right? It's like a fine powder almost, and so they obviously they had to, your multiple seals going back into where the lander, the LEM. But I wonder, as we like move out there and we're trying to build like an actual lunar outpost, or I imagine we'll come across the same problems on Mars. I wonder if there would be, I don't know, I'm just thinking some like Star Trek type, you walk into the vacuum room and a circular laser comes down and up or something. But it's because that stuff, if you bring it back into the living space, I mean, it's like nanoparticulate, right? It's like the 3D printing fumes that like you can't see but are like highly, highly damaging. Yeah, maybe that's what you need to do, man. Get in on that SpaceX venture. I get so distracted.
Space Force.
Yeah, right? Yeah, man. Hey, defense contract. That's where you get set for life, man. You got to go in and get those big, juicy defense contracts, but I don't know.
Yes. Yeah. We're trying.
Oh yeah. Hey man, who wouldn't, man? You got to get in. I think you need to. That's where it's at, man. That's where it's at. It's I know one of the problems with like, isn't the Mars rovers, the problems they have is the biggest problem. It's not shooting it. It's not shooting it's not hitting that hole in one, however many tens of millions of miles away. It's not driving it around. It's not the time delay. It's not even getting stuck, because they're very good. They have 6 wheels. They can all go independent.
Yeah.
It's pretty simple, actually, in all of my knowledge of road. It's the solar panels getting a fine coating of dust on them.
Right.
Cut off the power, the whole thing's screwed.
Right.
Maybe that's where you need to go, man. Just mount a little laser cleaner. Just because, I mean, they'll schedule their whole day's movements based on the weather. Right. Where's the dust coming? Because if we cover these solar panels, and it's so primitive, you'd think NASA would have it figured out, but with the real movement starts, like, all right, shift it, and they're almost like try to do like a little shimmy, knock it off, and it's like, is that the best we can do? we could put a rover on Mars and we're just shimmying the dust off. That's what you need to do, man. Is for everyone listening, October 1st, I'm actually having on a guy that helped design one of the Mars rovers. I'll plug you, Jeff. I'll be like, by the way, but sorry, keep interrupting. I'm sorry, I get excited. So soda blasting, move from there. All right.
So that's, in a nutshell, soda blasting and dry ice blasting. There's a cousin to soda blasting. It's calcium carbonate or crushed limestone. It can also be known as dolomite or dolomitic limestone, but ultimately, the big difference here is you didn't hear me say the word sodium, right? So that becomes what I call architect approved in terms of a media that can be used on a brick building because it does not run the risk of that condition, efflorescence, and it's very soft like soda. So back to the Mohs hardness scale, soda was 2.5. This crushed limestone is just slightly harder. It's a 3 on the scale, still classified as a soft media in our world. And all of a sudden, you have a great chemical-free, non-hazardous media that can do this gentle cleaning and do it very effectively. And we've supplied this product to very high-profile projects down in Washington, D.C. There is projects we've supplied in New York City and Philadelphia, but they all are old buildings or old monuments, and they're using this media for that restoration work, the cleaning that occurs before things get, restored to new.
Okay.
So that's out there. There's a media, it's plastic media. It's at basically the same hardness as the limestone, about a 3. That shows up a lot in aerospace. And that's used because you can reclaim this plastic media. It's still gentle. It's used by the military a lot, the Army and so on. And it's been around for years, actually. And that also is a form of media blasting.
Okay.
Next on our list would be walnut shells. And walnut shells register at a 3.5.
What?
And those have been around for a little while too. And so, if you need something to be a little more aggressive, or you want to try to use something that doesn't generate as much dust as soda may, there's a spot for walnut shells. A huge watch out is if you have an allergy, you cannot use walnut shells. It's on our website. That's like the first thing people say on our walnut shell page is make sure no one is allergic to the nuts, or you got a problem.
Yeah.
Right? So,
it's the last thing you think about.
Yeah, and that so 3.5 in this hardness scale means it's still friable, still going to break up upon impact, but you're going to start to feel the shells bounce back at you a little bit as you're blasting. You can just tell this is definitely a little more aggressive than the other medias I just mentioned.
Yeah.
And shells at a very high pressure, you might start to do damage, if you will, to wood substrates more than you would with the others, and you just would have to you have the right approach.
Yeah.
When you're consulting with people, they ask, well, what pressure should I use? It's really just start low, and you can always go high. That's always how we get people to make sure they're not doing any harm right off the bat.
Yeah. Well, that's pretty good advice for life in general. Just
it is.
yeah.
Sure, yeah.
The philosophy of surface cleaning. But walnut. I would have never in a million years. I mean, that's like World War I. They collected. Yeah. If you were a good patriotic American, what you would do is you would collect your peach cores. Why would you collect your peach cores? Because they use that in the gas masks.
Oh, really? I didn't know that. Yeah.
Never in a million years. But it's always some weird thing, right? So good war effort for cleaning the tanks. Save your walnut shells. Uncle Sam, you'd have your awesome propaganda poster. Save your walnut shells for the GIs. But what's after walnut shells? What's the next up?
So after shells. There's actually we don't carry this. It's more old school, but it shows up once in a while. It's actually corn cob.
Another one.
There's more repurposing. Yeah. But not. We don't find there's other medias that have taken over for corn cob. Corn cob needs special equipment, and it can get pricey, believe it or not, and all that stuff. So, but it's out there. It's another blast media in use today.
That's insane.
A bio product, right? So, and then after that, you start to step into more of a traditional hard abrasive, something that isn't going to break up upon impact, and instead is going to start to texture or profile a surface.
Okay.
And so next up is crushed recycled bottle glass.
Okay.
And an offshoot of that is glass bead. But ultimately, bottle glass has been around for about 10 years now. It's very economical. It's being processed and engineered for blasting, but it starts out as the bottles you and I are throwing away in our recycling bin. Mm-hmm. And what's unique about bottle glass is this might sound weird, but it's semi-soft. How's that? Or semi-hard, but it's a 6 to 6.5 on the hardness scale. And the best analogy I can come up with would be, if we drop a bottle onto concrete, right, onto the floor, it's going to shatter upon impact. However, it's still going to do some harm probably to the floor it hits. So that's what I mean. If you're glass blasting onto steel, it's going to create some type of profile or texture. When I say profile, I'm talking about peaks and valleys on the surface of the metal. And that's, sometimes you need that. You need that for any new paint or coating. It requires a certain surface profile so that it can adhere to and bond to that surface.
Yeah.
So glass is neat because, again, at a lower pressure, we supply contractors now that actually can use glass, on bow bottoms. So even though soda is still in use today for that type of work, the savvy contractors have figured out a way with the right technique. They can still do that bow bottom. It goes faster than soda because it's more aggressive, and it's creating a slight texture, but it's what the painters want to see, quite frankly, for repainting purposes. And they're not doing any underlying harm to the gel coat. And that is tricky. And certainly we have heard of people that when they don't really know what they're doing, all of a sudden they've poked a hole in the fiberglass.
Mm-hmm.
No one wants to do that. But it comes back to economics. Recycled fiberglass is a third of the cost of baking soda. So that's what drove people to try to find an alternative. And glass today is widely used in all sorts of sandblasting applications.
I wonder if there's I was just thinking of widely repurposed, what is, what's the next medium that's out there that's just untapped. I wonder if you could go super soft, but a high pressure. What if you could shred? I mean, I don't mean rip apart. I mean truly shred down to tiny little pieces. What if you could do that with plastic bags, shopping bags? Think Walmart bags.
Yeah.
I feel I don't know. Obviously, I don't know anything about surface blasting. What if you shredded that down to nothing and then just cranked up the PSI? It's still soft. I'll leave that to you though. You're the entrepreneur in this, not me. But
I mean, there are things that have crossed our desk from time to time, neat ideas and things like that. I mean, there's no way I could talk about all the different medias out there today, but for instance, cut wire is another example of a media that's out there that's used for specialty applications.
Okay.
There's ceramic beads. There's actually a lot of different choices today for people to use. The ones we're talking about are, I would call them most popular.
Okay.
And widely used by lots of different folks and companies and things like that.
Okay.
So the recycled bottle glass, we haven't really touched on mesh sizes, but this is a good example of, so glass is 6 or 6.5 on the hardness scale. That never changes. And you can order it, think like sandpaper, right? So 220 grit sandpaper is very fine. And an 80 grit sandpaper is going to be much coarser. And in the world of medias, it's the same. When we hear people talk about a 160 mesh glass, that's a super fine powder. And when you hit, they might instead be getting a 2040 mesh range. That's going to be more of a medium coarse grit. And you can customize your profile. So the larger the particle, that means it's going to create a much rougher surface, just like sandpaper. Mm-hmm. That's no different with regard to that.
Okay.
And then, so moving on from glass, there is, old school blasting, and it's still in use today, but sand is still used. It's becoming increasingly difficult to source silica sand. It's used a lot in fracking, so there's a demand for it in that business. It's actually being used a lot for beach replenishment, so it's not as available. And the biggest problem with sand is the dust. It contains silica, and no one wants to breathe in any form of silica dust. It leads to silicosis. And if you have alternatives, then why not use something where you still might breathe in some dust, but it would be classified as non-harmful or non-hazardous dust.
Okay.
So that's a huge difference from 20 years ago. Sand, if you start to Google, there's just a lot of controversy. OSHA is involved, and really, we don't sell silica sand, and we never will, and for all the right reasons.
Okay.
It's just, there's too many good alternatives. There's no reason for anyone to use silica sand.
Okay.
And then there's another old school media which is still in use. It's coal slag, and truly, that has its own set of issues from a health standpoint. So coal slag that's being repurposed, but it's a byproduct of coal production. There's a lot of it out there, so it's very inexpensive, but it contains a heavy metal called beryllium.
Okay.
And so that impacts also someone's lungs. No one wants to, I mean, you've heard of black lung disease,
yeah,
miners, and it's the same effect. And then it also has an environmental impact. You don't want to be just dumping beryllium into the ground and things like that.
Yeah.
So again, it's, I would say sand and coal slag are kind of cousins. They perform similarly. They're aggressive. They're inexpensive, but they have they have baggage, and to make most people recognize that for what it is.
Beryllium is, I mean, when we wanted to create a nuclear powered ramjet in the 50s, Project Pluto, that was one of the main, aside from the fact that it was a nuclear powered ramjet and everything that went with that, one of the other things was, the exhaust was beryllium oxide. And that's one thing I vividly remember from the documentary was like, getting the lungs and a horrific death, and they just said it's not something to toy with. But it seems like it sticks true even for surface blasting. Is say no to beryllium.
So someone watching might say, well, wait a minute, crushed glass is made from sand, and that's true, but different because it's processed glass. The dust from crushed glass is innocent. Instead of the dust being, say, free silica, so when you're using silica sand, it's free silica that gets released into the atmosphere. And when you're using the bottle glass, it's called amorphous silica. And, you still don't want to necessarily breathe that in, but it doesn't contain any free silica. So what I mean by that is free silica, if we breathe that in, it has what we just call a fish hook on it, on the molecule, and that fish hook latches onto your lungs, and it doesn't come out. With the glass, that fish hook is gone, and therefore, when you breathe in amorphous silica, you then can expel it or exhale it. It's not going to stick around in your lungs for any length of time. So there is a key difference there. And I know you have a smart audience, Tommy. I know someone will be wondering that, so I wanted to mention.
There's a lot smarter people than me, man. People always comment on. I'm sure someone's gonna tear me a new one. That's not what we do with the Mars rover. I'm like, all right, I'm sorry. I'm trying to piece this together. So I try to no, but that's good. They keep me learning. But so. Silica, what's after that? I know I said I'd let you go at 10. Like I said, man, you don't have to fit it all into today.
No, I know that. I mean, we'll spill over a little bit. It's not a problem.
All right.
So what's next is something that we have been involved with for about 8 years now. It's a product that comes out of Canada. It's called Jet Mag. And it's an engineered abrasive, and it basically is getting processed at a very high temperature. So it's kiln fired at 3,000 degrees Fahrenheit. That processing calcifies it and turns it into a very hard, aggressive abrasive. And it also burns away any, what I call nasties. But once they're done with the kiln, there is nothing nasty left in it. No heavy metals, no silica whatsoever, and so on. It's a product that's approved by the military for blasting, so it's a quality engineered abrasive. That's what when people call us, I don't want to use coal slag anymore. What do you have that will perform the same and not break my budget? That's our go-to in terms of a recommendation.
Okay.
It's a really good product. And when I said, so you can, if you drop a bottle of glass, it breaks on the floor. Jet Mag, if I could make a bottle out of Jet Mag, for instance, and dropped it, it won't break on the floor. That's how much harder it is.
It'll break the floor.
It's going to bounce back it.
Okay.
So much more aggressive.
Okay.
On that hardness scale I mentioned, the Jet Mag's a 7.5, and again, the glass was a 6. So that's used a lot for industrial blasting purposes. Think municipal water towers, right? Big projects in the field. That may be a media that they would choose for that type of project.
Okay.
Beyond that, there's garnet, and garnet is mined either in Australia or India primarily. There's some garnet mining in western part of our country, but most of it still comes from overseas. That's an 8 on the hardness scale. So it's much harder. But the shape of the crystal, if you remember, the soda was sharp and jagged like a knife. Garnet under a scope is what's referred to as subangular. So it's more rounded.
Okay.
It still can cut through paint and remove rust. Because of its density, it's reused a lot. So it can be, and it's also used for water jetting. So water jetting machines, which cut steel in a manufacturing environment, they actually rely on garnet to boost the cutting process, and it's a very, very popular application for the garnet.
Okay. How do you spell garnet?
It's Garnet.
Okay.
And it's, there's jewelry that's made out of garnet, and this is the same substance. It's just, how there's industrial diamonds, and you have diamond rings. It'd be the same principle. There's an industrial garnet, and then there's refined garnet for jewelry purposes and things like that.
Yeah. You don't want to break into the diamond industry. You don't want De Beers coming after you. You'll have some mercenaries at your company door. Yeah. Keep your head down. Don't peek over the parapet. Yeah.
And then you get into the metallics. So there's aluminum oxide that's used as a blast media. There's steel shot or steel grit that's used. Obviously, these are registering right at the top of the hardness scale. They are widely used for big blasting operations. So the military, for instance, there's an Army depot up in the Poconos, not far from where we are, called Tobyhanna. I've been up there. They have not one, but like 6 humongous blast rooms. So just picture a giant Army military vehicle being, driven into one of these rooms. They shut the door and they go to town. They start blasting it, and again, they're taking off all the old paint and before they can put new paint on it.
Yeah.
But there are some when I first got into the industry many years ago, I had no clue that, I thought of sandblasting kind of out in someone's backyard.
Yeah.
I didn't realize it was such a large scale process found at very large companies and military installations and so on. It's very impressive to see that scale of operation. It's quite impressive.
Oh yeah, I mean, I think I mentioned it the last episode. The M1 Abrams tank, which is, that is the tank of the world. That is the best tank in the world. We don't sell them to any allies. Someone's gonna fact check that and yell at me. But yeah, what they do is they'll take those things in these huge hangars, and it's almost like a hook. They'll take off the turret, and then they'll pick up the base, and they put it on one end, and so this whole 20-ton thing is just hanging. And what do they use? They use sand. They have multiple angles, and they close the huge blast doors. Like you said, they just go to town, and then they bring them out, look like new. But they do that for tanks coming back from the Middle East. That's how they So it's definitely not just like a DIY thing. It's defense industry.
And what's so like I said, there's a few other medias out there. It's impossible to include them all in this discussion, but that I think gives your viewers a really nice feel for the range that's out there, and the fact that you can customize your finish, and I think that's a piece of information a lot of people still don't realize. They still either are associating sandblasting as a destructive process, but they don't realize it actually now is trending towards a replacement method for current projects that are done with chemical strippers or solvents and things like that. So it's, my staff laughs at me sometimes, but I actually feel that sandblasting is going through a renaissance.
Oh yeah.
And my business is growing, throughout the years. But the reason it's growing is because people are looking for better alternatives. They need to go faster, be more effective. They don't want to do any environmental harm, and they want to, have a safe environment for their workers. And in today's blasting, you can check off all those boxes. We have been involved in very neat projects and complex projects where people were just blown away. They just didn't know that this could be done with today's equipment and so on. And then And so just to touch on the equipment a little bit, because this is a huge trend that's occurring as we speak. So vapor blasting or wet blasting is now in use much more than it ever was. How's that? And the latest innovation in my business is equipment where you can now combine water and the media into the same pressure vessel.
Okay.
And by doing that, and then you're still blasting, right? So you still need the air compressor, but all of a sudden that mixture means that when it comes out of the hose, you are not generating a bunch of dust. And there's a term that's used. It's really I'll qualify it, but dustless blasting is a term that we use ourselves, right? And the right way to explain that is there's less dust. It's not dust free though, but it's a term that was coined a while ago and it's caught on. So this dustless blasting process or this vapor blasting process, we work with a very large company that makes a real good line of this equipment. They've done studies, and their studies show that with their equipment in use, it's 92% less dust than it would be if you were not using water.
Oh, shit.
That's huge. Because there's still a bunch of blasting done in cities and urban environments. Nobody wants to be exposed to dust. Even if it's innocent dust, you still don't want that exposure to occur. So this trend towards using vapor blasters continues to grow, and we are a part of all that stuff. But it's really, and all those medias I mentioned, they can all be run through a vapor blaster. So all these machines are what are known as multimedia machines these days. So when this was invented, it was all about reducing the dust. Then everyone learned all of a sudden there was another benefit that no one realized. It was because we're using water, all of a sudden we can sandblast, vapor blast very thin sheet metal or even soft metals with a hard abrasive and not do any damage to the metal. So when you're dry blasting, you are creating a bunch of friction, and that friction turns into heat. When I was dry blasting aluminum or any soft metal, I would ruin it. I'm absolutely going to, they call it warping or stretching, but that metal can get deformed and it's no good anymore because of that heat factor. With the introduction of water in the process, that heat buildup is eliminated. So all of a sudden I can blast a thin piece of metal. I can achieve the surface profile I need for repainting purposes, and I don't have to worry that I'm going to ruin my piece of metal. That has actually become, so people like the fact we're not producing dust, but that has almost become more valuable. Yeah. The fact that we're not ruining the objects and can now do a one-step process. We can blast it with the water, and it's ready for paint. It's a really neat process. And we can even, by the way, run, so some viewers might say, well, wait a minute, what about steel? Isn't steel going to rust while I'm using water? Yes. However, you can run a very eco-friendly, fish-safe rust inhibitor through this equipment I'm talking about. Yeah. And by using the rust inhibitor, it prevents flash rust development for up to 2 or 3 days. So you still get a nice window before you have to worry about painting or whatever you're doing.
It's such like a simple thing, but I've always thought heat transfer is like the most interesting thing. Like I don't think I'd want to do that as a job. I'm sure if I went to like, get like an engineering degree, I'd hate it. But just heat transfer, just general. I mean, like I've got like a desktop, I've got like a laptop fan under this. I've got like a very low noise, low output, like vacuum attachment. I always make sure I do it on this desk because I know this desk stays cold because this room isn't heated. It's just little stuff. I've always been interested, but one of the things is always just that addition of water, and it's just that a million things that high specific heat capacity of water. It's always the tiniest things you never expect it for, but it's that minute stuff. I was gonna use dry ice to drop the temperature, and then the heat waste product from the the collision would, but I guess water is probably cheaper. Oh, yeah, and you're getting rid of dust. Never mind. So I completely overlooked that. So never mind. Scratch that.
Oh my God, that must be messy. It's not.
Yeah.
Power washing. That equipment uses, let's say, a lot of water per minute, 4 gallons per minute on average, right? This vapor blasting it's measured gallons per hour.
Wow.
And we're talking about 10 to 15 gallons per hour. That's it. That is not a mess. It actually, on a hot summer day, lots of times that water is evaporating as you go.
Yeah. Yeah. Damn.
Definitely. So sandblasting has evolved, right?
Yeah.
And I absolutely enjoy my job. I think it's neat to be involved in the period of time where there's a renaissance occurring for a very old school process.
Yeah. I think you need to do another episode and go full into the Renaissance, because I think that sounds interesting. If you want, I don't want to make you feel obligated, but I would love to have you on again, man. You're an interesting cat.
I would love to come on again, and I do have some new products that we could talk about.
Absolutely.
In a little while. So we've got a few things that we're ready to announce. I'd be happy to.
Please do, man. It's to me, it's free learning. Like, I was gonna sit in front of a YouTube video or listen to an audiobook. So to me, it's just, and it's interactive. I get the most. I'm spoiled. It's very last note, and then I'll let you go, and I'll email you, and we can set up another episode. Also, don't feel, I get really excited and I have guests on again and again, and I always have to be careful because I don't want to come across as like a clingy girlfriend, like, you're coming on every week. Like, no, it's just when you want, you can come on again. Don't feel obligated. It's but I was watching this video the other day of how the Soviets put out a natural gas fire that had been going for 1,065 days, and what they did is they detonated a nuke next to it because it starved all the oxygen, and it put out the fire. I was thinking with forest fires, I wonder, and this is going way off into the weeds, I was just thinking of like the ablative, the laser ablation. I wonder if you could somehow, I don't know, laser ablate like fire, because I know they do like, have you seen those videos recently of the helicopters, and they're carrying these, instead of a bucket of water, they have this big silver tank, and it's just burning diesel fuel, and they're doing burn lines to,
okay.
Yeah, I'd never seen it before. It looks crazy. It looks like lava, and but what they're doing is, they're burning lines through the forest to starve it of fuel. I wonder if you could just do that with like, again, what we said, like quadcopters. I wonder if you could do that, or those big 747s. Imagine if you could just, here's a fire in the mountains, and you just fly over with like an AC-130, but you just got a big laser, just burn it, ablation, just tear a line through it all. But yeah, I don't know. I'm getting, maybe that might be on.
Sounds in theory doable,
Yeah, ultimately would be abused and probably used in the war theater, but. Yeah. Hey man, that's how you get those sick defense contracts.
Yeah, that's right.
That's how you sneak into there. Yeah, man. Yeah. Well, sir, thank you for coming on. I'll email you, and I would love to hear about the sandblasting renaissance more in detail. And thanks for coming on, man. I learned a lot. Walnut shell, corn on the cob, not corn. Yeah, corn. Yeah, I learned a lot, man. I appreciate it, and I love learning. And thank you, man. And I've been meaning to say it for the last 2 episodes. That Earth map you have, that is badass. Over your, cool? Yeah, I don't know if it's mirrored. Yeah, on your wall, that's badass. I like that. That looks really cool. That looks like something you'd see in the Pentagon.
It reminds me it's just a big freaking world out there.
Yeah, dude, it's
just a speck,
Hey man, you gotta keep it in perspective. Jeff Paduano, thank you, sir. Thank you for coming on. I will link your companies and Spotify and all that for everyone listening. I'm going off on a rant. I'll email you and we'll set up a third one. All right, man.
Bye, Tommy. Have a good day, sir.
You too. God bless. Stay safe.
Bye.
Peace. Do